2.5, we're going to talk about zeros of polynomial functions. Now, if you check your gold sheet, we do 2.5 for a couple of days next week as well. So Monday and Tuesday, I think, are 2.5. So this is just like kind of skimming the surface of what we're getting into in 2.5. A lot of good information. So we're going to start with something called the linear factorization theorem. And you heard me talk about linear factorization in our notes in 2.3 when we verified a factor for a polynomial, and then we factored whatever was left over, and we wrote out all the factors of the polynomial, and all the factors were linear, so they had like x to the first in them. Then I said this is called the linear factorization. So linear factorization theorem tells us a few things. If a polynomial has degree n, and note that in order for it to be a polynomial, n would have to be greater than or equal to 0. So the smallest degree polynomial you can have is a 0 degree polynomial. That's a constant function. Okay, you can have linear, quadratic, cubic, up and up. Then it has how many zeros if you have degree n? N zeros. Now we said back in our graphing packet, we said at most n zeros. What we're talking about here today with the zeros are both real and imaginary. So in the graphing packet, when we were looking at the graphs, we only saw zeros that were x-intercepts in our graph. So sometimes our cubic polynomial crossed 3 times, and sometimes our cubic polynomial only crossed 1 time. So we said at most n zeros. But if you count all the imaginary zeros that don't show up on the graph, it will equal the degree. So they have n zeros, and if you have n zeros, that means you have a linear factor for each one of those zeros. You have n linear factors. So remember, when we're like writing factors for polynomials, like if I give you a list of zeros, you write them as like x minus k's. So if you just have a single linear factor, x minus k, then that means you have a linear polynomial with a degree equal to 1. Okay? So 1 degree means 1 linear factor. If I were to have 2 linear factors, I'm going to call it x minus k sub 1 and x minus k sub 2. So those are the k sub 1 and k sub 2 are whatever two zeros I gave you. You could think about, like, if I expand that, if I multiply this out, my largest exponent is going to be something x squared, right? So then this is quadratic, which is degree 2. So if you have a degree of 2, then you have 2 linear factors. And we can extend that. I'll just do one more. If you were to have 3 linear factors, and you think about doing all the distribution, first you multiply 2 of them, you'll get a quadratic, then you multiply by that third zero. In the end, the first terms, x times x times x, is going to give you something that is cubic or degree 3. So whatever your degree of your polynomial is, if I ask you to write a linear factorization, you should have that many factors listed. If you notice that you have a cubic polynomial, and in your linear factorization you only have 2 factors, you gotta go find that other factor for me. Okay? And they all need to be linear, x to the first, no quadratic factors. Okay. So something else to note, and I've sort of mentioned this briefly, and I think you know this from Algebra 2, but we're going to write it in our notebook so we have this information. Complex zeros always come in pairs. That's true for complex and also irrational zeros. And they come in the pairs of their conjugates. So if a plus bi is a 0, then a minus bi is a 0. So there could be examples where I give you a list of zeros for a polynomial, like this example at the bottom of the screen. Did everybody get the complex? Does anybody scroll down? Scroll down a little. In the example at the bottom of the screen, it says write the linear factorization for a polynomial with the given zeros, 0 and 2 plus I. There's something you fill in because you know about complex zeros. So if 2 plus I is a 0, what is another 0 of that polynomial? 2 minus I. It's complex conjugate. So I only have to give you one of them, and then you know the other one also exists. If you don't include the other 0, then you won't get a polynomial with real coefficients. And we want real coefficients in our polynomial because we don't know how to graph things with imaginary coefficients. So 0 and 2 plus I, then 2 minus I is also a 0. So fill in the blanks there if it's missing a 0. Yes, Nick?
Can you write that as 2 plus or minus I?
You could. Sure, but I already have 2 plus I, so I just wrote 2 minus I. And then it's asking you to do the linear factorization. So for linear factorization, you're going to put all of those back as x minus k's. So f of x equals, for our first 0 of 0, x minus 0 is just x. And then we have the 0, 2 plus I, so I could write that as x minus the quantity 2 plus I. And then the third 0 is 2 minus I, so I have x minus the quantity 2 minus I. So now this one is starting to look more like that one on the graphing packet that was blue, part C, where we had the irrational 1 plus or minus the square root of 3. So remember, I usually, this is the linear factorization. Maybe we should jot that down. Make a note to yourself. This is linear factorization. So if you were just asked to write the linear factorization of the polynomial, you've done it, which is what that example asks you to do. I think on the homework, they ask you to write the polynomial, so they mean the polynomial in standard form. So you actually want to go through and distribute. We want to do an example with imaginary zeros together. So we're actually going to write the polynomial in standard form. We've got to distribute all these things out. So remember, if I'm going to do that, I'm going to distribute this negative through my 0, 2 plus I and 2 minus I. So that's going to be x times x minus 2 minus I, x minus 2 plus I. X is pretty easy to distribute through later. So in your polynomial, when you're working with your complex or irrational zeros, if you multiply those two first, it should work out pretty nicely for you. So I'm going to do all the work with the last two factors first. You could, at this point, if you wanted to, do a trinomial times a trinomial. I don't want to do that because that's a lot of terms. That's 9 terms I'm going to produce, and I've got to be really careful with my multiplying, really careful with my signs, really careful with adding like terms. There's lots of room for a mistake there. So I do that thing that I did in our graphing packet, which is regroup. Notice here, once you distribute the negative, the first 2 terms are the same, right? So that's going to be x minus 2 and x minus 2. Now, there are 2 ways that you can then multiply or distribute this out. So you could think about this as A is x minus 2, and then it's minus B. B is just negative 1, or sorry, negative I. And then this is A plus B. And I had said back in the graphing packet, that's equal to A squared minus B squared. So I could do it that way. Or from yesterday, if you see this as like an imaginary 0 or an imaginary number, then you could think about it as a minus bi times a plus bi. And if you do that, then it's a squared plus b squared. So the difference is, depending on which way you choose to do it, is your last term, your b squared, going to be negative I times I, which is negative I squared, or are you going to just put in the coefficient to the i's, which is 1, or negative 1. So do you guys have a preference which one you want to do, red or green? Red. Okay, so if we do the red one, okay, then to distribute this out, we're going to take a squared, which is x minus 2 squared. And because it had the imaginaries units in the back, it's going to be plus b squared, but remember b in this is just the coefficient to I, so what's the coefficient to that I? 1 plus 1 squared. If you do the green version, it's going to be x minus 2 quantity squared minus I squared, which was minus I squared is minus negative 1, which will turn into plus 1. So we're going to get the same answer. Okay, so you choose which one you like. Now work this out. X minus 2 quantity squared, side note for some people, that is not x squared minus 4 or x squared plus 4. It's got a middle term. So if you need to write it out as x minus 2 times x minus 2, please do that. X minus 2 quantity squared is x squared minus 4x plus 4. And then I've got plus 1. So that's x squared minus 4x plus 5. And all the while I was multiplying everything by the x. So this is really like do this stuff and then multiply by x. Do this stuff and multiply by x. So bring that down. So then my final polynomial would be x cubed minus 4x squared plus 5x. Questions, concerns? Yes. That you're looking for, if you're factoring something, you're looking for things that multiply to make your last term, that add or subtract to make your middle term. Any other questions? Okay, so if you want to use my shortcuts for multiplying those things out, that's something you've got practice, right? So that you feel comfortable whether you're going to do, in this case, because it's complex, a squared plus b squared, or if you want to just default to a squared minus b squared and treat b like an I term, then you just use your cycles of I to reduce it. Okay, so either one of those is acceptable, but that's something that you should practice before a quiz or before a test. So make sure, like on your homework tonight, which is only 2 questions, you decide like what method you're going to do. Are you going to do trinomial times trinomial and do all the work? Are you going to group the first 2 terms together and use one of our patterns? Okay. But give that a practice and be very thoughtful about that. So those are going to